Okay, so polynomials are what? What are polynomials? What is a polynomial? More than one term. So a polynomial has more than one term, which means all of these up here are polynomials. Polynomials are built out of terms, which we call what? What's the one for one of them? A monomial. So polynomials are built out of monomials. And when you have two terms, it's called a binomial. Three terms is called a trinomial. Four terms is called a polynomial. Anything bigger than 3 is called a polynomial. What if the degree is to the, this is to the what degree? Why is this the third degree and not fourth? Because I see a 3 here and a 1 here. Why isn't it to the fourth? Because it's separated. Because it really, when you find the degree of the polynomial, you find the degree of each one, and then you pick the biggest one. How would you find the degree of this monomial? Add them all together. So you would stop adding as soon as you hit what kind of sign? A plus or a minus. Good. So what would be the degree of this monomial? 17. Good. The degree would be 17. All right? So that would just be called 17th degree. This is a third degree, so it's called a what? It's a trinomial, but it's a cubic trinomial because it's third degree. This is an 8th degree, so that would just be 8th degree. We don't have a word for that. All right, what about this one is second degree is called a quadratic. When it's the first degree, it's called linear. When it's to the 0, it's called constant. Good, yeah, it just means there's no variable. It's a constant. All right, fourth degree is quartic. Fifth degree is quintic. You have to memorize those. You just have to know them up to 5. Okay, so constant, linear, quadratic, cubic, quartic, quintic. All right, it's on your slides from yesterday, and you just have to know them. All right? So today we're going to talk about adding and subtracting polynomials and monomials, and we're going to start with talking about how to add and subtract monomials. So when we're adding monomials or subtracting monomials, the first thing you have to do is identify like terms. Can somebody reiterate to me what it means to be a like term? How do you know something is a like term? Brendan? What do you mean by that? Your coefficients don't have to be the same. No, the number in front doesn't have to be the same. No, like this is a like term. 4n m to the second plus 6m to the second. These are like terms. Exponents have to be the same and variables. Good. So like terms have to have the same exponent and the same variable. So that's what we have up here. So same exponent, same variables. If they do not, can you put them together? No, you cannot put them together unless they are like terms. So in this problem right here, A, we've got, this is the simplified step for this problem. So we started by identifying our like terms, which are the ones that are m to the third. 15m to the third plus 2m to the third gives us what? 17m to the third. How come it isn't 17m to the sixth? Because you're adding instead of multiplying. If you multiplied them, the exponent would increase, but you're just adding them together. So you're basically just saying, how many m to the thirds do I have? I have 17 of them. All right, why can't I add that with this? The exponents are different. So they have the same variable but different exponents, so you cannot add them. So this right here we would say is fully simplified. So you can't do anything else. That's as simple as it gets. All right, so how would we do B, C, and D? I want 3 people to come up and try it. 3 people to come up and try B, C, and D. Brendan, you want to do B? You can pick a different color if you want. Perfect. What does that arrow mean? Okay, how come you have an arrow between those two?
I was just saying 5 plus
Why though? Why 5? Why do those go together?
Because they're both the same.
Yeah, they're like terms, right? Do they have a variable? Do they have an exponent? They do, but it would be 1, right? Okay, so good. So you add together your constants, and then how come you got a negative 4x squared?
Because 3 plus negative 7 is...
Perfect. 3 plus negative 7 gives you negative 4x squared, and the exponent stays at 2. Good, perfect. All right, what is that? Name that for me. What kind of polynomial is that? Our answer.
A binomial.
It's a binomial, and it's quadratic. Good, because it's the second power. Okay, who can do C? Diego, C? Perfect. All right, I'm going to write it just a little bit bigger, but that's perfect. Okay, so the first thing Diego did is he did 0.9 minus 0.4, which gave him 0.5y to the 5th, and then he combined that with this. If there is no coefficient, what do you assume that it is? A 1. So he did 0.5 plus 1, which gave him 1.5y to the 5th, and then he still had this 0.5x to the 5th left, and so that one just stayed there. There was no like term with the x, so he just left it alone. And he wrote it with the x first, but it doesn't matter. Either one can go in either order because it's plus, and plus means that it's commutative, so the order doesn't matter. Okay, so either one is fine. Typically, I write it in alphabetical order, so I would have written it the other way, just like Diego did. But it really doesn't matter because they have the same degree. Okay, what is this? Identify this for me. Name it.
This is
It's a binomial. It's a quintic binomial because this is the 5th degree. Good. Quintic binomial. Quintic, you can remember, like quintuplets means there's 5 babies. Quint means 5. I'm trying to think of other, yeah. There's been like octuplets. I think that might be the most. Are there any other words that start with quint?
quintillion.
Quintillion? Yeah, what does quintillion mean? Oh, yeah. Something big, right? Huge number? Okay. Are there any other quint numbers? Squint? Does that mean you close 5 eyes? No? All right. Quint would have to be the prefix. I can't think of anything besides quintuplets, which is 5 babies. So, what?
You have to close your eyes to 0.5.
Oh, okay. Close them to 0.5 of a centimeter. All right, good. Okay, can somebody do D? Can somebody do D? Angel? All right, y.
Positive 2x minus 1x is...
But these are all monomials, right? This all goes together. So is this term like this term? Yes, and it's like this term?
Yes.
So you don't break them up. You look at it like it's one whole thing. So if this is 2, what's this? What's the coefficient here?
2.
No, right in front of here if I don't see. 1, and this is also.
1.
So basically you're doing 2 minus 1 minus 1, which would be what? 2 minus 1 minus 1. What's 2 minus 1?
Oh, okay, so it's 0.
0, good. So it's 0x squared y, but really do you even need the x squared y then? So it would just be what?
3, 1.
What?
3, 1.
There's no y's left.
3.
Nope. 0, just 0. This whole thing is one term. So that all goes together. You don't split up the x's and the y's. So this is like saying 2 minus 1 minus 1, which just gives you 0. So it would be 0x squared y. But if it's 0 times that, that still just gives you 0. This is all one term, so you don't ever split that up.
Okay.
You would only split it up if there were plus and minus. Thank you for volunteering for that one. It was a tricky one. Okay, so when you have terms that are like this, these are exactly the same. So it's just like having one variable. That whole monomial goes together. All right, so that one ends up being 0. Oh, so yeah, that would be a constant. Okay. So do you think anything's different when you're adding or subtracting polynomials? Like, take a look at A here. This is a what? It's got 2 terms?
It has 2 terms and 1 parenthesis.
So it's 2 terms is called a binomial, and this is called a trinomial. All right, does anything really change here? No? So it's really just like exactly the same as the one we just did before. So all we have to do here is exactly like we did before, just find like terms. So what term is like this one? X squared. Okay, what's 2x plus x squared? 3x squared. What term is like this one? What's negative 1 plus 3? Positive or negative? And then is this like anything? No? So I just have a minus 1 at the end. And that's my answer. So you do it the exact same way. In this case, we can almost pretend the parentheses aren't there. What would be different here, though? What would be different in this one? I'm going to erase this so you can see it.
Yeah, the negative 3.
Hang on one second. What would be different about this one? Well, physically, how does it look different than this one? It's a subtraction. So what do you think that means? Since there's a subtraction sign outside the parentheses, what do you think that means? You have to put it together with what? Like this negative sign goes with what? 3a. And also, so what do you call that when you're like distributive property? So you have to distribute this sign to everything here, which basically means all these signs will flip. Okay? So yes, it only distributes to the stuff that's after it. So it doesn't go with the first stuff. So this stays a to the 4th minus 2a. But then this becomes what? Negative 3a to the 4th plus 3a. Good job. And then minus 1. Okay, so you distribute the negative sign. You only have to do that if it's a subtraction problem. If it's addition, just like this, you leave it alone. It's basically just like the parentheses disappear. So, yeah, go ahead. What about what negative 1? What about it? It already was negative. So it stays negative. Because a positive times a negative stays a negative. None of the signs would change. Okay, so then what are my like terms here? What's like this one? Negative 3a is like that one. What's like this one? 3a. And then this one is alone. Okay, so put together your double lines. What does that give you? This is a 1. What's 1 minus 3? Negative 2a to the, all right. What would this give us? Plus 1a or just a. And then minus 1. Perfect. Okay, so this has how many terms? So it's a trinomial. And it's to the 4th degree, which means it's a quartic. Quartic trinomial. Okay, what's the biggest thing to remember if it's subtraction? Distribute your negative sign. All right, go do these 4 at your boards.